The dark energy camera was designed to peer into the farthest reaches of the universe. But because it can observe a large portion of the sky, it also helps us search for objects much closer to home. Leaving Earth behind, we see the orbits of planets around the Sun. Mercury, Venus, Earth, and Mars. Jupiter, Saturn, Uranus, and Neptune. But our solar system includes many other objects, not just planets. Astronomers have used the dark energy camera to find numerous small, icy bodies in the outer reaches of the solar system. We have tracked thousands of these objects, which reside far away from the Sun, past the most distant planet, Neptune. They make up what's called the Kuiper Belt. Billions of years ago, everything we see here likely revolved in the same plane. But the massive planet's gravity tugged the lightweight Kuiper Belt objects into different orbits. They now travel far above and below the plane of the planet's orbits. Each tiny icy world we discover helps us answer questions about the history of our solar system. What did it look like billions of years ago when the planets were taking shape? We can't go back in time, but we can observe other planetary systems in the process of forming. Light detected by GPI reveals what happens when planets form around nearby stars. We can imagine traveling to one such place, so far away that its light takes more than 60 years to reach us. This star is more massive and much brighter than the Sun. The star and its planetary system are less than 30 million years old, mere infants compared to our own middle-aged solar system. Dust and debris form a disk around the star. Some tiny objects in this disk will end up like our Kuiper Belt, icy bodies at the edge of the system. GPI allows us to peer into the center of the disk. Astronomers then use computers and the laws of physics to simulate what might be happening. We have discovered one giant planet, more than a dozen times more massive than Jupiter, whose gravity has sculpted the dusty disk into a warped spiral. Could something similar have happened in our solar system billions of years ago? One of the ways ALMA has revolutionized our view of the universe is by giving us a close-up look at young planetary systems. Here, we are seeing not just the leftovers of planet formation, but the actual disk of material from which planets take shape. This is ALMA's image of BDS 70, a very young star, less than 10 million years old. Its debris disk looks more like a ring of dust surrounding the star, with a large gap where at least one Jupiter-sized planet is forming. That planet has a small disk of its own, where moons could be forming around it. Here, we're seeing the results of a computer simulation, which we can compare with data from ALMA and other telescopes to help astronomers understand how planets grow. Perhaps our solar system looked like this billions of years ago, a family of planets taking shape.